All right, let's get into geologic maps. This is going to be a relatively short and sweet unit here. Most of the information you're going to want to know is going to be at the end, so still don't fast forward. Okay, so geologic maps. What are they? They are very distinct, colorful maps that display information on the types of rocks and geologic features in the area. So they use a lot of things like index fossils, relative dating, things that we've learned about previously to kind of create a history of the area. So with geologic maps, they are separated by geologic units. And so those are going to be in the key. I'll show you later, like the units are that little colorful square. And a geologic unit is just a volume of a certain type of rock of a specific age. So rocks that are from a similar age that are similar rocks, they're like the same rock layer, that's going to be one geologic unit. And so those are important in being able to describe the history of the Earth and kind of describe what events happened during that time period. And so then what gets between two geologic units are going to be contacts. So those are the boundaries between rocks that are of different types or ages, which are geologic units. And geologic maps, they just show rock ages, types of like structures like anticlines and synclines and faults, and then types of rocks as well. So here are some geologic maps. This is North America here. So you can see right here's a line, that's a contact. Right here's a line, it's a contact between this geologic unit and these geologic units. You can see, let's look at this red rock right here. So this red rock up in Canada, all the way up into here, is all of the same type of rock and of the same age. So what I think this is, right in here is shale. So this green one is going to be shale. So this is all the same rock from the same age. This is a lot of it. And we're getting into that and trying to transport that down to here at this point in time with our current administration. So what's happening is we are getting rid of all of this green stuff, allowing for other rocks to come on top of it, and we're moving it down to here to burn for fuel. So essentially what we're doing is we are destroying this whole geologic unit. So that's not a great thing. Okay, so here is another really good geologic map. This is of Colorado here. The thing that you're going to want to know for this geologic unit is that in the key here, they go from oldest on the bottom to youngest on the top. They also show you the age. So the Precambrian age is the oldest age here. It's also a really, really long age. And the Quaternary age is what we're in right now. So this is the newest deposit of rock. So right here, we're going to go, let's look for the oldest rock here from the Precambrian age. It's metamorphic, sedimentary, and igneous rocks all together, because this is like hundreds of millions of years ago. All of this is a mountain range, is going to be a lot of igneous, metamorphic, and sedimentary rock. And this is from hundreds of millions of years ago. But this little tan colored here, this unconsolidated deposit, essentially what that is just sediment. There hasn't been enough time for this to turn into a metamorphic or igneous rock through the rock cycle. So this has all just been, essentially what happened was this all got weathered away. People live here. This is where people live. So that's why it all got weathered away. We destroyed those rock layers, and then we created this little sedimentary area due to our industrialization and due to a lot of these rivers, they will deposit sediment on the outsides of the rivers. So flooding events deposit sediment, and that's how you get this little geologic unit. So it just kind of tells you the history of the Earth, where you live. It gives you a good idea of where to build, where not to build. A lot of the times you don't want to build on unconsolidated deposits or sedimentary rock because you need to build on bedrock. Otherwise, if there's moving or shaking, those buildings are going to collapse and be destroyed. All right, so here is just one last really good picture of a geologic map. These are all just different geologic units here, separated by contacts, which are those lines. And these letters here tell you what time period it is and what type of rock it is. So this is Quaternary, and it looks like limestone right in here. So this is in Colorado, right here in the Springs, this is going to be like the Garden of the Gods. Quaternary period, sedimentary rock, all throughout the Garden of the Gods, you get this sedimentary structure, and then the mountains on the outside are sedimentary mountains. And so you've got a little geologic unit inside of these other geologic units because something happened here to where the rock got eroded and became its own rock. So this is the really important slide here. It's going to be on the quiz. So the importance of geologic maps, they may be kind of hard to read, but they're really important because you can discover mineral and energy resources. So like if you know there's a lot of coal underneath somewhere, we're moving towards coal again for some reason, which is a really outdated energy resource, but we're going to be starting to look at geologic maps for that. So we're going to use science to go against science, kind of, which is a juxtaposition. It's kind of funny. And you discover different minerals. So like with Apple, they need to have all sorts of different like silica and other sorts of minerals to create these microchips. So they're going to look at areas where there might be certain types of silica or certain other types of minerals inside of mountains, and they'll say that's a good place to go mine. And then another reason why they're important is to assess potential for natural hazards. Like I said, if you're building on top of like sedimentary rock, there's not a lot of bedrock, so this area is really prone to shaking and like disturbances, so it's going to do this type of thing. And if you put something like a building on top of that and it does this, the building is going to collapse. So that's really important. And then the same thing for suitability of construction sites. A lot of construction foremen and construction workers, before they have to go to work, they have to determine the suitability of their site. And so they get a scientist to get a geologic map and interpret that geologic map and see if that site is going to be suitable to have some large-scale construction going on. And then the last thing is they convey information about geologic history. So like I said, if you go back to this one, you can look right here, you can see that this mountain range is a really, really old mountain range. It was developed in the Precambrian age. If you find certain fossils in here, you can make a good hypothesis on your observation saying that, hey, there were dinosaurs here at this time because we know the age of the rock, we have these fossils, all the evidence is there. And so like with the Garden of the Gods in here where we've got, actually it's like right in here, where we've got all this sedimentary rock, you get a lot of like fossilization in there. So you can kind of tell like how the Garden of the Gods formed and what kind of life forms were in there 300 million years ago, what kinds were in there 100 million years ago. So there's a really good geologic record there. So that's why geologic maps are very important for the discovery of energy resources and minerals, assessing the potential for natural hazards, and looking at the suitability of construction sites. And then, to me, the most important one is conveying information about geologic history, because if you don't know how the world worked hundreds of millions of years ago, then how are you going to know how the world is going to continue to work in the future? Because it doesn't really change all that much. We do a lot of changing to it, but essentially the world, the earth kind of keeps itself stable. So it's really important to know how it keeps itself stable and what happened millions of years ago. So that's super important to know, in my opinion. Other than that, that's going to be all you're going to need to know for these quizzes and eventually the unit post test. Like always, go ahead, give me a shout out if you have any questions or need additional help. I am here for you. Have a good week.